component. I've added a rigid body to it, have not changed any of the default settings, and we've added this move with force script. It has a movement force value of 10, and you can kind of see how the object bounces around. Now
Selamlar tekrar. So started the recording. I started sharing my screen, and now I realized that I forgot something. Not in this game, not in this. So in our last scripts, I have not talked about rotation. It's actually self-explanatory, but I still want to go over that real quickly. So just like transform.translate method is changing the position of our objects. Transform.rotate changes the rotation of our object. And it takes a vector tree, which will be defined as this. So it will change your rotation so that you look towards this direction. And to smoothen this up a bit, we again use time.delta time. And to modify this speed within the editor, we multiply this by turn speed. And we also use vector.down. As you see, it's a shorthand for writing vector 3 0 minus 1 0, and vector 3 up is the shorthand for writing vector 0 1 0. So these are these will affect y direction. So if I click my object's y direction will be, I'm not sure if so when I click to my game, and when I do this when I click Q and E, it starts to turn. So I said something wrong. It doesn't make you look to this vector tree, but instead it lets you turn around this vector tree. So we will be turning around y axis, which will be this this green arrow. And if I click space again, and translate it back. So okay, now we have covered all the things in this part. So this was moving our transform with inputs. Now, like I said, we will go talk about some rigid body physics. And inside this project, which I will be uploading to the Drive folder, so you can copy some scripts from here, and you can also experiment a little bit. You can go to another scene, which will be called rigid body physics. And now we are inside rigid body physics scene, and I'm going to choose my rigid body based box, which will be the box we will be moving. And again, it has 4 different scripts added, and we will go over them one by one. So first of all is moving it with force. And similarly to our previous examples, we check our inputs by getKey methods, not by getKey down methods, remember that. And we are adding force by this amount, which should move our object forward. And I can adjust this force with an editor. So if I see this in action, when I hit W, it's adding some force, but it's not enough, when I hold too much, then it starts to add force like this, and I can rotate back. And now if I click A, it should give a force in the left direction. And if I hit D, it should give force in the right direction. So it's going towards this section. But it's not taking into account its local coordinates. Instead, it's taking account world coordinates. So no matter how my object is facing, when I click right, it will try to go right sides of my world. Okay, so this is kind of problematic. It should take into account its own coordinates. By the way, currently when I click WASD, I cannot move it like I did, because now it's diagonally placed, and it's taking a lot of force to move it now. But if I click W and A at the same time, then it's trying to go in this direction and also in this direction. So the net result will be adding a force in this direction. So now I can move. If I click W and D at the same time, I'm able to move. But this is obviously not what we wanted. This could be useful if you have a ball, if you have a something like a pinball game maybe. But if you have a cube, I don't think this is the right way to go. So instead we will try another example. So we've covered what these are doing. So these are, like I said, world coordinates. And now I'm going to disable the script and enable another one. Now I'm going to click this one. So I will be moving with force, and I will use transform rotation. So let's see what this does. And so it again does a similar thing. Okay. Now it's taking into, let me just use that again. Now it's using local transform. So when I click W, it does that. But when I click A, it should go left like it does. But now I'm going to hit W again. And now W moves it forward, but forward, since it's taking local coordinate into account, forward is this vector. So it's trying to go in this direction. Let me start that again. So I will go W. So I will be adding force in this direction, which it does. Okay. Now if I hit W again, it can't go anywhere because it's trying to go towards the ground. And if I click left, now it's taking account this direction, and now it's going to go left like this. And if I go forward again, it will try to move, go in this direction, add force in this direction. So I go to right instead, not forward, and let's see how this code is written. So again, this checks for WASD keys, and when I hit W, it gets transforms forward direction and multiplies it with a basic multiplier. And since it is using transforms forwards and transforms right direction, it's not quite useful in many games, because it's changing constantly, and your W will not behave as the player expected. Just keep in mind that since we are dealing with rigid bodies, we are using fixed updates as we should be doing. And in our previous example, we were using fixed update again. So these two are quite similar. The difference is this is using global vectors, and instead this is using local vectors. So okay, now I'm going to go to this, and I'm going to disable this one, and I'm going to enable rotate with mouse, or actually let's enable jump script. So now if I hit space, even if I'm not touching to the ground, it gets me a force. Gives me a force like this. So it's like a jetpack kind of thing. It's not actually a jump, but it's like a jetpack. So when I click space, I'm able to go upwards a little bit. And if I hold space, nothing happens because it's, the script basically captures get key event. Let's see how it does though. Okay, so inside updates, we check input.get key down, and if should jump equals false, and I have pressed space key in this frame, then should jump becomes true, right? And it is here. So both fixed update and update can reach to this variable. And inside our fixed updates, if I should jump, my rigid body will be, we will add some force to our rigid body, right? In this direction, which is shorthand for writing vector 3, 0, 1, 0. And I'm modifying this by jump force, which is a variable that I can change from the editor. And if should jump gets activated, I am adding force in upwards direction, and then I set should jump to false, so that I can capture another event like this. Since this will be false, because I set it to false here, it will check its back. I mean, so we have a loop. We have a nice loop. So this might be kind of confusing, but um, I mean, let me ask you something. Why did we not check um, something like this? So we could actually, let me do that. So instead of all that, we could write something like this inside our fixed updates, right? So if I hit space, I add some force to my object. Why didn't we do like that? There's a good reason for that, by the way. Any ideas? You can even explain it in Turkish. So if you remember in our previous lectures, when we are trying to build our racing game, I said that we are writing not the best code, but the most practical one inside our player movements behavior. So let's see what we have did. So inside our fixed updates, we checked if A button is clicked, and we added some force to that. But I said that it's not the best way. I mean, for get key, it's okay. But for get key down, it's not okay, because get key and get key down events are checked inside our update function, while our add force method is getting called inside our fixed update function. So we need to separate those two. If my input is given in my frame, then I should record it somewhere. I mean, I should save it somewhere. Then when my physics engine asks me, what should I do? Then I should say that, in our last frame update, an input like that was given. So now it's better that you add some force to this object. So there's a two-step process that we should use. And let me just open this script again, which will be jump script. So this is why I should do a two-step process. So reading get key down in fix. I mean, there's a nice explanation here, so I'm going to read that aloud. Reading get key down in fixed update is unreliable. Meaning that not always I am able to capture get key down inside fixed update. So this won't be behaving like I want. I actually want to save the script and see it inside my game. So it says that it's not reliable. That means that when I hit space, it won't be called every time. And I am clicking it multiple times. And sometimes it really doesn't capture. So I clicked 3 times and it didn't capture. So this is why it's unreliable. And this is because this method actually gets checked inside my update function. Sorry, this method is checked with each frame update, not with each engine tick, physics engine tick. So if there's a delay between my frame update and my physics engine tick, then this event gets lost and I cannot capture it. Did I make myself clear? Burası bayağı önemli. Size bayağı zaman kaybettirebilir oyun yaparken. O yüzden sorular varsa alayım. Hatta Türkçe de anlatayım biraz. Şimdi daha önce şey söylemiştik. Update frame rate'e göre çağrılıyor. Cihazınız yüksek performanslıysa saniyede 100 kere, 120 kere çağrılabiliyor. Performans düştüğünde 30'lara, 40'lara düşebiliyor. Fixed update ise her fizik motoru tikinde çağrılıyor. Yani fizik motor tiki de öncelikli bayağı. Unity hani şaşırmasın, fizikle ilgili şeyleri doğru hesaplasın diye. Öncelikli olduğundan hep işlem gücünü fizik motoru hesaplamalarına ayırıyor. Bundan dolayı fizik motorunun çağrılması, dolayısıyla fixed update'in çağrılması hep aynı sıklıkta. İşte saniyede 50'dir, saniyede 100'dür. Hani siz bunu değiştirebiliyorsunuz. Bu sabit sayıyı değiştirebiliyorsunuz. Ama belirlediğiniz sayı oyun boyunca fizik motorunun çağrılma sıklığını belirliyor. Dolayısıyla bazı durumlarda frame oluşturma hızınız, yani FPS'nizle fizik motorunun çağrılma hızı bayağı ayrı olabiliyor. Yani sıklıkları ayrı olabiliyor bunların. Dolayısıyla yani son frame'de siz tuşa bastıysanız ve hani uzunca bir süre fizik motorunun çağrılması gelmediyse bazen bu eventleri kaçırabiliyorsunuz. Yani space'e bassanız bile algılayamayabiliyor fizik motoru. Yani fixed update bunu yakalayamayabiliyor. O yüzden update içinde tıkladım mı ben space'e diye soruyorum. Tıkladıysam onu bir değişkene kaydediyorum. Fizik motoru içinde de bunu kontrol ediyorum. Eğer zıplamam gerektiği gibi bir durum var mı? Öyleyse o zaman ben zıplıyorum. Yukarı doğru bir kuvvet uyguluyorum. Ve sonra da tabii should jump'ı false'a set ediyorum ki hani artık o değişkeni bir daha dinleyip bir dahaki fizik update'imde bir daha zıplamayayım diye. Sonra bir dahaki update frame'inde yine kontrol ediyorum space'e basıldı mı. Space'e basıldıysa should jump'ı true yapıyorum. Sonra artık ne zaman fizik motoru bunu kontrol ederse, nasılsa ben bir yere kaydettim ya zıplamam gerekiyor mu gerekmiyor mu. Kaydettiğim için artık capture'layamama gibi bir sorunum kalmıyor ve düzgün bir şekilde zıplama eylemini kullanıcıya gösterebiliyorum. Anlaşıldı mı burası? Önemli çünkü.
Evet hocam.
So now I'm going to remove this bad code, and I'm going to enable those again. And I'm going to read the command lines here, so that we will say the same thing, but from a different perspective with different words. Reading get key down in fixed update is unreliable. It's possible for two updates have passed before a fixed update call, which could lead to missing the key down. For example, if your updates and fixed updates methods gets called in this order, then I might miss something. So in our first update call, my user pressed space, but there's not a fixed update method that is called immediately after this update call. So this, when the second update method call is called, this is overridden. So I mean, since I did not press space in this frame, I wasn't able to capture get key down events. I mean, since I'm still holding space, I can capture get key events. It's okay. But get key down events is being overwritten with this line. And now inside fixed update, get key down is false and get key is true, which means that I'm not able to capture get key down event, which is why we don't read get key down in fixed updates. It gave a note. Let's read that as well. Get key returns true for every frame and would still be fine to use, but in this case, we don't want to add force every frame they hold space. So in our game, as you recall, I want to add force when I'm holding my buttons. So this is why I used get key events, and this is why it's okay to check it inside fixed update methods. But you know, it's always better practice to check all those events inside update methods, and even get key. I mean, if you, it doesn't change anything, but it's better practice to check user input events inside update method and handle those events in fixed update method if you have a rigid body. Okay. So now that we get this out of the way, let's go back to, I mean, I'm going to close this one as well. So let's go back to our code, our game actually. Oops. So now if I click my objects, I mean, I'm going to play it one last time. Yeah, now it's able to capture every event as you see from the scene view. So it's working as it should work. And now I'm going to disable jump script, and I'm going to enable rotate with mouse script. So now this lets me turn towards the direction of my mouse, which is quite useful in first-person shooter games, or even in I don't know, some third-person shooter games, etc. So let's see how we can achieve this. So I'm going to click the script and open it. I want it to open in this window. So just let me close those and reopen. Okay, great. So now we are using turn speed again to adjust it from the editor. And inside each update, I'm getting my mouse positions x-axis, and this is the let's see what this is actually. So since the x direction is this part, this axis, you know, in our world, x is in this direction, so this is our x-axis. I'm going to take the x value of the virtual axis identified by axis name, and I'm going to take x-axis of my mouse basically. So after that, I'm going to rotate towards this point with this turn speed, and I will be turning around this vector, which is vector3.up, and also I will be moving. I will be turning relative to space.worlds. So this applies transformation relative to the world coordinate system, and this is why when we call vector3.up, I guess it's going to take into account this world vectors. And now I want to play one more time, and as you see, it's able to turn to where I am, like this. Okay, so I can mix some behaviors together. So I'm going to use move with force, jump, and rotate with mouse together. If I use them together, you will see that I mean, it will follow my mouse, and I'm able to jump like this. And there's also one more thing that I wanted to show you, which will be move with force, use transform rotation, clamp velocity. Sorry. So move with, actually I'm going to edit like this. Actually, I'm going to take its name and copy this here, and I added something. So now this moves my object by adding some force, and it clamps my velocity so it doesn't go above a certain threshold. And For that, it checks my velocity inside my FixedUpdate method. And if my magnitude is above a certain threshold, which we call maximum velocity, we do nothing. We return, we get out of this FixedUpdate method. So we don't even arrive in this line of code. And, you know, we, I mean, to affect my player, we have to wait that my velocity gets below our maximum velocity, you know. And this is done by friction in our world. So I mean, as you see, I'm not able to move them very quickly. By the way, if I want to, I mean, I want my player to not, if I want my object to not rotate, then one quick way to do that is to clamp its position. So where do we do that? Let me just. So normally, there's a choice that you can stop this object from moving in certain axes. I'm trying to find this. It should be here somewhere, but for some reason I'm not able to see that. Is it because of the version, Unity version? I'm not sure, but I should be able to stop my object. Oh, okay, it's here. So if I freeze my rotation in blue arrow and red arrow, so X and Z, I'm not going to rotate around those axes, even if I add force. So it will be looking like this. So when I add force, oops, nothing is happening for some reason. I'm just going to try something real quick. So this uses WASD. Okay. So now I'm able to. Okay, but this is not my intended behavior. What happens if I freeze position like this? Let's check. Not intended behavior. No. Yeah, I mean, there's a way to, stabilize this object by freezing some of those fields, but I should mess with them a little bit. In our next lecture, I will show you how to do that. But if you don't have any more questions, we can wrap up for today. And next lecture, hopefully we will be seeing, I'm not sure if I'm not sure actually, but if we have time, we will be talking about character controller, which is Unity's Unity's suggested way of controlling player characters, and also nav mesh, which is the short name for navigation mesh, and also we can maybe talk a little bit about animations, movement with animation. And okay, that's all I wanted to cover for today. So see you next lecture.
Thank you for the lecture.
Thank you.
No problem. I will be uploading those example projects to Drive, and you will be able to use those pre-made scripts and also some scripts, some projects that has already made assets for you, and these can be useful for your homework. So see you later.
See you.